Okay, this is our first lesson for Algebra 1. Okay, the lesson, as you see, it's 1-1, operations in real numbers. Okay, remember that there are different types of real numbers. Okay, and we're going to be talking about different types of real numbers in this particular lesson. So pipe down and pay attention. If you don't pay attention, it's going to be really hard. And you're like, "Oh, it's really hard," when you don't even pay attention. So let's get to it. Okay, let's look at this lesson here. Okay, or the critique and explain at the very least. Cindy and Victor are playing a math game. The winner must get 3 in a row of the same type of real number and justify how the numbers are alike. Cindy said that she won because she was able to get three rational numbers on a diagonal. Victor said he won with 3 positive numbers in a column. Okay, notice here, beep, bop, boop. Oh, wow, 3 real numbers. Huh, 3 in a row, I win. Okay, notice how this, same thing. Also, I win. Keep this in mind. For part A, can both players say they won for different reasons? Well, let's look at the one that's in purple, the one that I just circled right here, okay? Notice 1.3, 2/5, and 27. There's actually different qualifications, okay? 27 is a whole number. Okay, whereas 2/5 and 1/3, that is a rational number. Okay, however, all three these numbers together are known as real numbers. Okay, so real numbers are basically anything that when you simplify it, it's not a non-repeating decimal. And I'll show you guys examples of what is not a real number. In other words, an irrational number. Look at radical 10 and pi, okay? No, not the pie that you eat, more so the pie like the number, okay? If we were to pull up good old decimals, let's pull up decimals as an example here, okay? I'm going to type the word pi, okay? Pi. Look, it's a decimal. But notice how this decimal continues on forever and ever, and the decimal does not repeat, okay? Since the decimal does not repeat, therefore we can say it's what's called an irrational number, okay? So pi and radical 10 are irrational, okay? They're irrational. So we can actually say in this case for the one in blue, the ones that are circled right here, right here, right here, he did not win because 1.3 is considered to be a real number. This and this are irrational, whereas this here is a real number, okay? So can we make other groups using the numbers shown, using the same kinds of numbers? Let's actually talk about different kinds of numbers, okay? So I'm going to pull up my whiteboard / my, what's it called? The, Microsoft Word, okay? There's different kinds of numbers, okay? The first number that we're going to be talking about is what's known as whole numbers, okay? And whole numbers as examples, actually, no, I take it back, not even whole numbers. Let's erase this. Let's actually call it natural numbers, okay? And an example of a natural number is 1, 2, 3, ... As long as it's positive, as long as it's not a decimal, and as long as there's no 0, you're good. The next one is whole numbers. Whole numbers are 0, 1, 2, ... Okay, notice how it includes number 0. The next one is what's known as integers. And examples of integers are like -2, -1, -3, also 1, also 0, ... Let's keep going. And the group of integers are known also as rational numbers. Okay, rational numbers. And that could be an example of 1/2, 0.7, -0.3, -1/4, as long as they're fractions or decimals and they're simplified. So I can make this a little bit smaller to make the circle a little bit bigger, because in this entire group, okay, these are known as real numbers. Those are all real numbers, okay? 4 different types of real numbers: natural, whole, integers, and rational, okay? This is the group, okay? These are all elements, okay, of real numbers, okay? this is all the set of real numbers. And when we talk about sets, let's take a look at the lesson here. When we talk about set, it's a group of something, okay? For example, sports. Sports. Well, what are the elements of sports? Football, baseball, soccer, hockey, basketball. Those are elements of sports, and sports are the sets, okay? So let's talk about this set right here, beep, bop, boop, okay? 1 through 10 are the elements of set A. In other words, A has these 10 numbers inside, okay? If I were to take a subset, I take a part of the entire set. Notice how 2, 4, 6, 8, 10 are within this set, but it's a subset. Why? Because it's part of it. It's not the entire thing, it's part of it, okay? Let's look at the triad here real quick. Which numbers in set A are elements of both odd numbers and multiples of 3, okay? We're going to call this subset C. Beep, bop, boop. Okay, let's find out what numbers are multiples of 3 and odd numbers, okay? Let's circle all the odd numbers right now. Boop, beep, bop, boop, beep. Okay, now let's circle using a different color. Let's use a vomit green. Which ones are both multiples of 3 and an odd number? Based on the ones that we just circled. And notice how that's the only one. Actually, we have one more. This is another one, 3 and 9. So we can say 3 and 9 are the only two elements in that set that are both odd and multiples of 3, okay? Any questions? There shouldn't be. Let's move on, okay? So as we just talked about, okay, comparing and ordering real numbers, okay? Here's your hint. You need to convert every single number into a decimal. If you don't convert it to a decimal, it will be really hard, okay? Every single one of these numbers can be turned into a decimal. Remember that this right here, you can use division to convert it to a decimal, okay? Any questions? If there are, okay, here we go. So we're putting these numbers from smallest to biggest, okay? 40 over 11 is 3.63. 18 over 6, which is this, it's 3. Square root of 10 is 3.2. When we put them in order, that's the smallest one. That's the second smallest. That's the third smallest, or the biggest. Okay, let's take a look at this. Okay, we can do this very quickly. And guess what? You can use good old decimals for this. Okay, so let's do example 2 right here. Okay, we had 0.25, radical 1 over 9. As well, if we go back, okay, 6 over 25. Okay, again, convert them to decimals. And again, you can use decimals. We know 0.25 is 0.25. That's obvious. Let's do now the square root of 1 over 9. Okay, if you want to pull up the keyboard, let's pull up the keyboard. Okay, and then let's do square root of 1 divided by 9. 0.3333. Okay, so that's this right here. I'll change it to a different color to show you guys what this is. 0.333 something. Okay, 6 over 25. Okay, 6 divided by 25. Look, it's a decimal. Isn't that crazy? 0.24. Okay, 0.24 is the number. Okay, so this is 0.24. So we need to figure out of all the numbers, which one's the biggest, which one's the smallest. 0.24 is the smallest. So 6 over 25 is the smallest. Then it's 0.25. Then it's whoa. I actually read the actual number. It's radical 1 over 9. Okay, there you go. Not difficult. Okay, here we go. Let's get to it. Moving on now to another example. I'll skip part B because it's the same thing. Okay, are the sum of two rational numbers always a rational number? That is 100% yes. If I take a fraction, add it with another fraction, I'm going to get another fraction. Even though it'll look different, it's still a rational number, okay? But if I take two rational numbers, when I multiply, it's the same thing. It's always going to be a rational number. Rational times rational, also rational, okay? So let's talk about this, okay? What I'm going to do, okay? I'm use the same whiteboard. Beep. Oop, that's not what I wanted to do. Okay, let's do that. Beep, ba-da, beep, bop, boop, boop, okay? R is rational, I is irrational, okay? So rational plus rational, that's rational. Rational minus rational, that's rational. Rational times rational is rational. And then rational divided by rational is rational, okay? This is always, okay, always. It is always going to be rational, no matter what two numbers I add or subtract or multiply or divide that are both rational, okay? But now let's talk about something different, okay? Okay, let's do this. Rational plus irrational, like 7 plus radical 3. Well, that's 7 plus radical 3. And this is irrational, no matter what, okay? The same goes for irrational plus irrational. It's still going to be irrational, okay? Let's talk about rational minus irrational. Well, 7 minus radical 3 is just 7 minus radical 3. And that is irrational, okay? The same goes for irrational multiplied by irrational. That is going to be also irrational. Not multiplied, but subtracted by, okay? All right, what about this? Okay, rational multiplied by irrational, okay? Depending on the number, okay? Depending on the number. Actually, that's no matter what, okay? So if I had 7 multiplied by radical 3, well, that's going to be 7 radical 3. That's going to be irrational, okay? No matter what. But what about this? Irrational multiplied by irrational. It could be rational or irrational, okay? And I'll show you one basic example, okay? Radical, let's go 12, okay? Multiplied by radical 3. That is radical 36, which is 6, and that is rational, okay? So it does make a difference, essentially. One more. Rational divided by irrational. That is always going to be irrational. So like 7 divided by radical 3, that's going to be 7 divided by radical 3. So that's going to be irrational, okay? But the same goes for irrational divided by irrational, okay? That'll sometimes be both, okay? And it's basically the same example, okay? Irrational divided by irrational, that is going to be either rational or irrational also. It's got the same context. You cannot just divide radical 12 by radical 3, okay? It really just depends on the number essentially, okay? So that goes hand in hand, all right? Here we go, moving on. Okay, so get that idea. As we move on here, is the sum of rational, irrational? We already talked about that. It's always going to be irrational. Is a product of a rational and an irrational always irrational or irrational? Yes, 100% of the time. Okay, so we already talked about these questions. Is the difference between a rational and irrational number always irrational? Yes. When we subtract it, it's always going to be irrational, irregardless. Okay, as we move on. Oh, that's it. Okay, definitely know this, okay? The idea of rational and irrational numbers and sets and subsets, okay? That concludes lesson 1-1. We have 1-2 coming at you in just a few. Enjoy all that fun stuff. Have a great morning, afternoon, or whenever you're watching this. So have fun. Yippee.